Let me introduce myself. My name is Almaira Azzahra Imami. I am the student of Tridinanti University at Industrial Engineering. Here, I wanna review journal for my assignment by my lecture subject Manufacturing Process, Mr. Dery Mariadi. Here, I wanna talk about analysis of GHG emission from cargo vehicles in megacities, the case of the metropolitan zone of the Valley of Mexico. Okay, next, introduce. What is GHG emission? GHG emission is greenhouse gas emission. This greenhouse gas can occur naturally but can also by human activities. The research discuss about cities consume the majority of energy and contribute significantly to GHG emission. Transportation sector is a major contributor, particularly like commercial vehicles. This study evaluates GHG emission in Mexico City with a focus on electric vans and cargo bikes for last mile deliveries. Next, past research. Several analyses have been conducted in previous research as follows. The first, Gustafsson et al. Analysis of GHG emission in heavy-duty vehicles. The second is Koch et al. Impact of logistic depots and fleets on urban emission. And the third is Galindo Muro et al. Optimal routing for deliveries using electric vans and e-bikes. Next, method and result. Wheel-to-wheel analysis was used to evaluate emission from both the full supply chain and vehicles operation. There are 4 combinations of transportation modes. Number 1 is electric van, number 2 electric vans plus electric cargo bikes or e-bikes, number 3 diesel vans plus e-bikes, and number 4 only diesel vans. Next, you can look in the figure 3 for combination of transportation modes depending on their energy sources and diagram of the optimal routes using van or a combination of van and e-bikes. The optimal logistic routing planning and the full consume fossil or electricity for each option were based on the solution provided by the study developed by Galindo Muro et al., which considered the minimization of distance, slope, and energy of the CVs as shown in the figure 3. Next, GHG emission result by Mexico City case study. The first is electric van plus e-bikes reduce emission by 24% compared to diesel van plus e-bikes. The second is electric van alone is 1.3 times more efficient than diesel van. And the third is combination of electric van plus e-bikes offers the lowest emission. You can look in the figure 5, diagram of wheel-to-wheel GHG emission of the optimal routes for each combination of transportation modes in Mexico by 2020. In accordance with the result traveling the entire delivery route by using only the diesel vans release 1.3 times more GHG emission from wheel-to-wheel than the electric vans, 5 times more that is combination with e-bikes, and 6.5 times more than the electric vans combined with e-bike. You can look diesel vans in point 1397, electric vans in point 1049, diesel van plus e-bike in point 284, and electric vans plus e-bike in point 217. Okay, next. Okay, you can look in the table 3, present energy consumption and GHG emission generation from wheel to wheel, depending on whether an electric or diesel van is used or whether it is used in combination with e-bikes. Wheel-to-wheel energy consumption and GHG emission of optimal logistic route in Mexico 2020. Next, energy mix and emission worldwide. Countries with a higher percentage of renewables have lower wheel-to-wheel emission for electric vehicles. In countries relying on fossil fuels, like South Africa and India, electric vehicles may not provide a significant reduction in emission. You can look in the table 4, contribution of major energy categories of electricity generation, wheel-to-wheel electricity, emission factor, and emission of the full electric optimal route by country in 2020. Next, based on the analysis of the research, these are the results. First, electric vans and e-bikes combination produce 24% less GHG emission compared to the diesel van and e-bikes combination. The second is using an electric van with e-bikes reduce total GHG emission by 80% compared to using only a diesel van. And the third is the combination of electric vans and e-bikes proved to be the most sustainable option for reducing emission in last mile deliveries. Okay, next, research implication. Transition to clean energy. The use of electric vehicles effectively reduces emission, but optimal benefits depend on the use of renewable energy. It's like decarbonizing the grid, smart charging and load management, and decentralized renewables energy generation. You can read the explanation and example of each point yourself. Okay, next, future recommendation. The first, I suggest to focus on increasing the share of renewable energy for electricity generation. The second, encourage multimodal transport solution. It's like electric vans and bikes for urban logistic. And the third is implement optimal route design to further minimize emission. Okay, last conclusion. Based on the research discussed and the previous slide, it can be concluded. Number one is electrification of vehicles is essential for reducing GHG emission in megacities. Number two is combining electric vans and e-bikes is a sustainable solution for last mile deliveries. And number three is global emission vary greatly depending on the country energy mix, making clean energy a crucial factor. Okay, maybe that's all the discussion from me. I hope a little discussion from me can be useful for us. Thank you and see you next time.